All right. An inverted conical tank is being filled with water at a rate of 10 cubic feet per minute. The tank measures 24 feet tall, has a base, not a base diameter of 20 feet. At what rate is the height of the water increasing when the diameter of the water is 12 feet? Can you appreciate that when you first look at this problem, how complicated it sounds? And yet we'll be able to come up with a solution. It's not going to be really fast, but not going to be that bad. You will have a problem like this on your test. So this is an inverted conical tank. And what's happening is, well, first of all, it measures 24 feet high and it measures 20 feet in diameter. And it's being filled with water. And there's a time when the water has a certain height. We know that the diameter of the water is currently 12 feet. But is the diameter of the water changing? Yeah. So I'm actually going to take that 12 off so as not to confuse you. Okay, because that is changing, so we can't leave that as constant. But the structure itself is the same. So we're wondering the height of the water. The water level is changing. Obviously, the height of the cone is not, but the height of the water is. So we're talking about volume, everything else we're talking about with respect to the water. So do you remember the formula for volume of a cone? Well, what's the area of the base? Pi r squared is the area of the base. Then we multiply by h, and we multiply by 1/3. Okay. So, what pieces do we currently know? V prime is 10. And we know that the current diameter of the water is 12. So that means that the current radius is 6. Why did I choose to write it in terms of radius? Because that's in our equation. All right. What are we looking for in this problem? What are we trying to find? H prime. And that's the question. At what rate is the height of the water increasing when the radius is 6? Or question. All right. So we have a problem here, and this is what you have to anticipate when you do this stuff. At this point, I want to take the derivative, but I always kind of glance ahead and I say, when I take the derivative, what will I come up with, and is it sufficient or not? So when you take the derivative of this, what will you have to use? The product rule. Does everybody see you got to use the product rule here? The r squared and the h. So if I use the product rule, true or false, I'll come up with an h prime at some point. And I want to find the h prime. True or false, I'll come up with an r prime at some point. True. Do you have r prime? Do you have any way of finding r prime? No. So therefore, we have to get rid of r. We don't want r at all. We have no way. We could figure out what the current radius is. It's 6, and we could figure out the current height. But we have no way of figuring out, what r prime is. So r has to go away. So I set up a ratio, a proportion. And the proportion is this. The radius divided by the height will always be at a constant proportion. What is the current radius of the cone? 10. Of the cone, not of the water. The water is changing. The cone is not. That's the diameter. What's the height? 24. So here's what we're trying to do, folks. This will hopefully make sense to you. Okay, it says that it's 20 feet in diameter. Suppose the water was 10 feet diameter. What would the height of the water be? 12. Why? It's half, right? It's 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 increasing at a constant rate. There's a relationship between these two. So what I could do is I could cross multiply and get 24r is equal to 10h, and then solve for r by dividing by 24. I get r is equal to divide by 2. I get 5 over 12. 5 over 12h. So whatever the height is, I would multiply it by 5/12, and that would give me the radius. That's the relationship between the two. So now I can get rid of that r in the original formula by plugging in 5/12 h, and that way I won't have to use the product rule, and I won't come up with an r prime, because that, again, is the problem for us. So we write it out. The volume is equal to 1/3 pi times 5 over 12 quantity squared. Whoop, got that h. All right, what's 5 over 12 squared? 25 over 12. No, 25 over 144. And 144 times 3 is 432. So we've got 25 over 432 times pi. And then how many h's do we have? H cubed. So now I'm going to take the derivative of that. So v prime and 75 over 432, that does reduce to 25 over 144. And then what's going to happen here? H squared, H prime. Yeah, I'm confident. All right, so we now solve. What is v prime? 10 equals 25 over 144 pi times h squared times h prime. Do you know what h is right now? We don't. Can we find h? Yeah. We know what the current radius is, don't we? What's the current radius? 6. So 6 equals 5 over 12 times h. How would I find h? Times by 12/5. So I get 72 over 5 is equal to h. It's kind of messy, but it's part of the nature of dealing with calculus sometimes. 25 divided by 144 times pi, and then times 72 divided by 5, that quantity squared. And I get 113.097. So 10 is equal to 113.097 times h prime. And now I will take, if I take 10 divided by 113.097, I get 0.088. What are my units? What are we what are we finding the derivative of? The height. And the height is measured in feet per minute. It's kind of an involved problem, huh? If this problem was given to you on the AP exam, it wouldn't be part of the multiple choice. That would be part of the free response. And in the free response, they would give you about 15 minutes to do that problem. Okay. So, all right. Good work. Not easy stuff, but you can see that today's lesson a little bit more challenging than yesterday's. Again, if you take problems 1 through 12 and then try 16 and 18, we'll go with those for today. We'll add just a little bit more tomorrow, and then we'll wrap up our related rate section. Okay? So I'm going to shut the video off, and Colton, you got a question?